We are building the number hunt program from the YByte Python curriculum available at www.ybyte.in. Number hunt is an interesting interactive program where the computer first chooses a number and we have to guess it, and then the tables turn. We choose a number and the computer must guess it. Now, when it comes to computer guessing, we need to think of some algorithms where we can make sure that the computer is able to correctly guess our number in an efficient manner. We have seen two algorithms so far where first one is extremely conservative but correct, where computer goes in steps of one, obviously takes a long time. Next one we saw where computer takes a larger step, but we realize that as we come closer to the number, in fact, we must reduce the step, otherwise we end up in an infinite loop. Having seen all of this, let's now focus on something which is correct as well as more efficient than either of these algorithms, which is called the binary search. Now, before I go there, however, let's just think a little bit about, these algorithms that we have looked at. Now, one thing about any algorithm is that the number of attempts that we need to guess a number depends strongly on the chosen number. This is inevitable. Hence, a metric to think about is, well, what is the largest number of steps that I need to take to get to any number? In fact, we can look at the average number of steps as well. But let's just look at the largest number. Now, for example, let's take the conservative algorithm where we increase guess by 1 at each step. If we start at 1, it will take us 50 attempts to guess to 50, 100 attempts to get to 100, and so on and so forth. But the number 3, we could get in just 3 attempts. So, like I said, it depends on the number chosen. But clearly, this is extremely inefficient because to get to, say, something like 90, we need 90 attempts, which is very, very slow. On the other hand, if we let's say made step size of 10, started at 1, well, it will take us 2 attempts to get to 11, but it will take us, say, 12 attempts to get to 54. In fact, you can argue that, the maximum number of attempts with the code that we have is 20. That will be to some numbers in the 90s. And what we notice is that, the number of attempts to a given number will actually change depending on the starting point, depending on the step size we've taken, and so on and so forth. But still, there's an intuition that comes out from all of these observations, which is that in general, if we want to minimize the number of steps for every number that could be chosen, well, we need to make step size large in the beginning because that helped, when we moved aggressively towards the number, let's say. But we must also reduce our steps as we go on, and in fact, binary search achieves all of this. If you recall the second algorithm that we saw, we did move quite well in the beginning, but then after a while we faltered because we just did not know how to go, beyond, let's say, changing the direction and reducing the step. But binary search achieves all of this. The idea in binary search is to keep eliminating half of the range, half of the search area at every step. And the way this is done is that we basically keep track of the search range in two variables called low and high. And we always keep guessing at their midpoints, which is approximately their average value. The reason I'm calling approximate will become clear as we go on. Example speaks, an example will make it very, very clear. So let's just look at an example. Let's say, we have chosen number 37 and the computer is trying to guess it. Now, remember in the beginning, all we know is that, computer is we know that the number is between 1 and 100. So we say, okay, low is 1 and high is 100 because the number is in between them. Now I make a guess which is approximately the average of 1 and 100. Now the average of 1 and 100 is actually 50.5. So what I did here was to use round function. I will talk about that later on in the code. I guess 50 and I asked my player, is the number that you have chosen larger than this or smaller than this? I tell smaller than this. The moment this happens, I know that the number is not here. In fact, I can completely eliminate this from the list. From the search area. Now, how I do this is by saying that, okay, look, high, which was 100 in the beginning, will now become 50. And now I know that my number is between 1 and 50. Now, once again, I choose a number which is, say, a round of low plus high by 2, and hence 26. Again, notice round here is not so important, but the intuition is more important, that I'm going right in the middle of this range and I'm saying, okay, is it 26? Now, remember the number was 37. So my user tells me, well, no, it's larger than 26. The moment that happens, I go and eliminate this part of the range from my search area. And hence I set my low to 26. So now my low is 26, high is 50. I ask a number again. Well, is my number, say, 38? Now again, I'm going right in between these two, and which is 38. My number is 37. My user tells me, look, my number is smaller than that. Now, the moment the user does this, I know I have eliminated anything beyond 38, right? So essentially, notice that my search area is getting smaller and smaller really, really fast, and I'm going to converge to the right number in a few more attempts. The important bit to understand here is that this algorithm is in fact, at an intuitive level, meeting the criteria that we thought is a good one, which is that start with a large step, which is what we do. For example, here, go in the middle, we make a step of 25, but keep reducing the step in a very smart manner. Now, because of this low and high, we will change direction as well as keep reducing, the steps. And in fact, no matter what number we take, in fact, we can show that between say 1 and 100, we can get to that in say at most 7 attempts. And that can be shown mathematically. So this is the intuition here. This is the idea here. We will next, we'll look at this more closely as we write code for this. But think about this for a moment and see how beautifully, how efficiently, and how correctly this is picking up the number that we have chosen. If you think this way of learning helps you, well, do look at our website, ybyte.in. There's a lot of material that will be of interest to you. Take care. Thank you so much. Bye-bye.